All right, so you're going to start with your policy, is that right?
Yes, I am. So we'll move through this session a little bit more technical, and Roland will keep me on track if I end up talking too much. So we've got quite a few slides to get through, and I'm not going to try and sort of cover all the detail. We'll just once over lightly and really encourage you, if you do want more information, we can certainly be very happy to provide that. We've got lots of research reports and more detailed reports on the information we've done. So in terms of our policy development, we use this research to develop our technical specification. And then this supports our annual network measurement and assessment. So that policy sets up for what we're trying to measure, and then we go and measure, and then our teams do the assessment. And then obviously the key thing with this was the implementation and uptake. And this is both internal and external. So when you develop a new policy, you've obviously got to take your own road organisation staff along with you to make sure they fully understand, but we work very closely with our suppliers as well. So this is obviously WDM do our measurement for us, but also our contractors, who we have a collaborative partnership with, they need to understand what these measurements mean, because they're critical in terms of then going and doing the appropriate treatments. So our specification defines what we need to do, but it also has a set of explanatory notes. And this is really what we call non-contractual, because the specification is contractual. But the notes just give a bit of detail and background and explanation as to some of the technical information that is tied up in the specification. And then obviously we've modified it to reflect our ongoing learnings as we've gone along the journey. Now the key thing was justifying, and we talked earlier about the benefit cost ratio, but justification was critical. So from a crash savings perspective, we've put a value on life and a serious injury. And I mean, I know it sounds a bit callous putting it into monetary terms, but when you're trying to do an assessment of where you're going to invest, we've had to do that. So there's an economic evaluation process that's used, and the economic cost of life is valued, and that can be then used to develop the cost versus the benefits of addressing those. And because this was a maintenance type activity, we had to do that to justify the additional investment. And it was also important in terms of selling the concept, because obviously maintenance requires justification, but in New Zealand it's funded quite differently from improvements. So we had to justify why the extra investment in making this improvement was necessary. And also it was important to do a peer review to confirm that our statistical analysis was appropriate, because there is some assumptions made, and as you saw, it was a second order relationship. And obviously we had to make some assumptions about the wet road crash rate, and of course with the variable climate and weather in New Zealand, that does vary year on year, and we'll see that as we go through. So some assumptions had to be made, but the basis of it was helping to support the development of the specification and the investment. And of course then the big question is, did it work? And we'll talk about that as we go through, and we'll show you some graphs to show what it looks like. And I just want to flag at this time too, the cost of measurement, that can be a bit daunting initially. You might think, well, that's a lot of money to measure the network. But when you look at the savings, it's a very small component for us in terms of the money we invest in improving skid resistance. The cost of the measurement, while it's not insignificant, is just so critical to gather that really important data, which you can use to analyse the survey. And for us, it's had a lot of spin-off benefits as well, which we'll talk about as we go through. So I just wanted to cover off some broad principles around surface friction. Apologies if you know all this detail, but it's quite important in terms of looking at the various components that go into skid resistance. So first thing is the macro texture, and this is sort of the distance between the sort of the top of the chip and the substrate that it's adhered to. And for us, that's a key issue in terms of New Zealand roads, because we do get flushing where the binder rises up or the aggregate is punched into the substrate, and we get a loss of texture. Then that can lead to problems with the tyre interface, particularly on our wet roads. So this is where the hysteresis comes into effect. So there's a shot just showing the tyre imprint. And with our very wet climate, it's really important that we get a lot of water on our roads. We've got to make sure that we can drain that away, which is where the macro texture comes in. Now, micro texture is obviously the actual aggregate themselves. It's the little fine edges on the aggregate itself. And again, this is the predominant component of the skid resistance that we're measuring. And it really is determined by the aggregate properties. And we do have problems in New Zealand. A lot of our roads are chip sealed surfaces, and we do get, as I said, the flushing, we get the binder rise. and we did a big research a few years ago as to why we're getting bleeding. So this is where the binder livens up and then it gets spread and tracked down the road. And we found that water was getting into our chip seal surfaces. And a hot day, you'd get bubbling, and that would then liven up the viscosity of the bitumen, and then that would be tracked by vehicle hot tires all down the road, and it would coat the surface of the chip, and we'd lose our micro texture. So that's really important. But the other important factor is obviously the tire tread itself. And this is the one we really struggled over the number of years to try and find out exactly what goes into the design of tires, treads, and the assessment. It's a very competitive, commercially sensitive, secret environment. So we have really struggled. But to me, it's 50% of the component, really. We can make the road safe, but the tires have got to be acceptable for those road conditions. And I'm sure the tire manufacturers do a lot of work in this area, but they are a bit reluctant to actually make a lot of that information available. But the combined effect obviously is what makes it conducive to people's braking ability in the vehicle that they're traveling in. So using those principles, we developed our T10 specification. And as I said, it's a technical specification covering a whole range of elements, plus the explanatory notes. It talks about the measurement of the road network. It defines investigatory levels. So these are triggers for us to say, if it falls below this value, we need to start investigating. And then when we developed the policy, we found that we needed to develop threshold levels. So these are levels where we actually then need to go and intervene because we feel they've gone below a level of safety that's acceptable. And then when you're looking at annual surveys and comparing them over time, we found we had significant climatic effects in terms of year on year. So if we had a really dry summer in New Zealand, we found that the results were skewed. So we have made a correction factor to our results, which we call the ESC. So this is the equilibrium SCRIM coefficient. So this averages out over a 3 or 4 year period and helps us then do those year-on-year comparisons. We're also measuring every 10 meters. So this means that we can intervene if we've got spot treatments. We can go and intervene with those short lengths if they're really bad, but obviously looking at the way the network is segmented and trying to keep to our surface lengths, our reseal lengths, which could be anywhere from, so I'm thinking of metric 500 meters up to 1 to 2 kilometers, depending on the consistency of the surface. And we've got triggers for both macro texture and micro texture. So macro being the depth of the mean profile depth that's acceptable. It's got trigger levels, and also the micro texture, which is the SCRIM measurement and the aggregate that's used. Now, when we go and survey, the initial results are uncorrected. So we produce what we call an exception report. And this is just the raw data, and it really flags up if we've got any really bad areas across our network. We can go out and intervene. The survey happens in summer, and often a lot of the treatments are summer treatments, particularly if we have to go and resurface. So this exception report gives us that real initial, if anything's significantly bad, we can go and investigate and maybe do a treatment before winter comes when the risk goes up. Then we use all this information and do a prioritization and look at the risk across the network and where we're going to invest. Then the information is seasonally corrected. And then obviously that triggers a report for our teams to then go out and target and start designing their surface treatments. And as we've gone through, we've used a lot of this information to help then refine our investigatory levels. And I'm about to show you a table now, which to me is probably the crux of the presentation. So this really, in one table, describes how we assess the risk on our network. So we've divided it up into site categories, which are based on risk. So our highest risk will be site category 1. And this is typically on the approaches to railway crossings, traffic signals, pedestrian crossings. These are where we've got high braking. And so this is our highest surface friction coefficient. This is where the demand is high. And then as you move through each site category, we accept the lower level of friction because the risks are less. So on our tight curves, steep downhill grades, and then you move into level 3, which is approaches to intersections and lesser downhill grades, right through down to level 5, which is your divided carriageways. So event-free, typically heavy braking is less frequent because it's generally free flow. And often a lot of these divided carriageways have median barriers and side barriers, so they're generally at a far higher standard than some of the site category 1, 2, and 3 areas. So this then helps us to assess the information and divvy it up and then use that for prioritization in terms of the information that comes. Now, in terms of the measurement, obviously measuring a whole road network every year is very complex. For us, it's the time of year is critical. Obviously, what happens is there's fine aggregates polish the stone over the summer, so the worst results are in the summer. So that's when we measure, and then as the winter rains come and that fine grit polishes up the roughens up the stones, we find that the measurements in winter are a lot better, albeit that's when the roads are a lot wetter. The distances travelled, obviously 13,000 miles of road network measured every year is a significant amount, a lot of distance to be travelled, and a lot of areas are quite remote too. So a lot of technology in terms of the improvements to GPS have helped with the locational accuracy of some of our very remote areas of New Zealand. Also, alignment when you're doing an annual survey, big discussion about whether the vehicle will drive within the lane or the wheel path. So on a tight curve, will they follow where most vehicles track, which might be across the left-hand line. Obviously, we drive on the left-hand side of the road in New Zealand, but it would be the reverse in the States. But where people track so outside the lane and use the shoulder, that was the big question about whether we followed the wheel paths or whether we kept to the lane. And in terms of the wheel paths, typically back in the early days, SCRIM was only measuring the left-hand wheel path. That was deemed to be the highest polished worst case scenario. We were quite concerned about differential friction between the two wheel paths, so we measure both wheel paths. And we're really thinking about all road users. Obviously got motorcyclists who would track maybe between wheel paths, but could stray into either or. So we wanted to make sure we got the full assessment of what the surface friction was within the lane. The speed of the survey again was a challenge in the early days. The speed was a lot slower than it was now, and that can create some traffic management issues. So vehicles travelling along at a slower speed than normal traffic can hold traffic up. And some people have known to be panicked about the water application. So they see a vehicle travelling with water dribbling out the back, and they get quite concerned about what the problem might be. And then obviously in some of the, not so bad in New Zealand, we've got heaps of water, but I certainly know in Australia, water was a major problem in terms of just access to it, because when you're doing some of the really long road networks in remote areas, water can be a challenge. So getting access to water may be a challenge in some of your remote, drier areas. And obviously the weather in the seasons has a massive part to play. So the survey, very difficult. They can't survey when it's raining, so they've got to try and pick the drier season. And obviously in New Zealand, we get quite significant seasonal changes. We can have a wet spring, we can have a wet start to summer, and then we can also start to have an early winter as well. So it does change, and it looks like we are starting to see things move more towards the end of summer. So we're getting longer, hotter summers. And also temperature has a major part to play. So unlike the other condition measures, there's so many variables in terms of the skid resistance measurement. And I just wanted to show a graph of what that actually looks like. So this next table just shows you that over a given day, in terms of measuring skid resistance, and this is using a British pendulum tester and British pendulum numbers, but you can see early in the morning, the air temperature was 14 degrees Celsius. Apologies for the Celsius, not Fahrenheit. And the road temperature was about 16. And then you can see through the day, by the time we got just after 12 noon, the air temperatures increased significantly up to 23, and the road temperature is up to 38. And in New Zealand, we have measured temperatures above 50 degrees in the middle of summer. When we start to get our bleeding, we've measured well over 50 degrees, so they do get very hot. But you can see what impact that's had on the surface friction measurements. So these are some of the challenges in terms of measurement, is there's a lot of corrections need to be applied if you're going to normalise this information. So the equipment, obviously, we have been using SCRIM for a while, and this is the continuous slip vehicle that has a motorcycle tyre angled at 20 degrees. We've got one on each side to measure both wheel paths, and it skids down our highway. And it was interesting talking to the operators that in the early days they didn't go through many tyres, but now they go through a huge number of tyres every season, which for us is just a good sign to show that our roads are really nice and have got really good friction, and it's really starting to wear those tyres. So that's just an anecdotal measure of how effective our policy's been in terms of making our roads safer. Now, it's really important in terms of, because of the complexities of measuring skid resistance, that the equipment needs to be calibrated. And so it gets sent back to the UK every year and has to be recalibrated. And this helps us to maintain the consistency of the measurement year on year. And also it's important in terms of that locational accuracy. And we need a big vehicle like this because of our challenging road network. So it's a lot of kilometres or miles to travel every year. So we do need to make sure that it's a really robust piece of equipment. Now, we've got a little TV clip we just thought we'd show you, which just again helps to describe, probably better than I have, the SCRIM machine.
So I think, Mark, we're having some trouble with the sound, and I think that it looks a little bit slow. It may have a little bit of a hard time juggling all of the demands here. So, hold on, let me see if
we'll just carry on. No problems at all.
Okay. Oh, hold on. We may have found a workaround. All right, see if it's...
Now, no one likes being stuck behind a slow-moving truck. But what if you knew that truck was doing a job which could potentially save your life? As James Ransley explains, a couple of state-of-the-art trucks are out checking the state of our highways.
Kevin Menchie's been driving trucks for most of his life.
A great way to see the country. I really enjoy myself doing it.
And now he's driving this truck for the New Zealand Transport Agency, one of only 2 in the world. Kitted out with all the latest technology, it's designed to check the state of our highways.
And we use that information then to decide on the priority about where we need to go in and resurface the road.
This is the skid assembly cabinet.
Inside a specially made bald tyre, water is poured in front of it to recreate a vehicle braking and skidding during an accident.
As the truck is driving down the road, the operator can lower these inside the cab, and this wheel will naturally try and straighten and measure the skid resistance of the roads.
Over the next few months, the NZTA's 2 trucks will cover 22,000 kilometres of the country's state highway.
Each summer, the trucks are brought over from the United Kingdom, where they're constantly upgraded with new technology. At a cost of nearly $2 million a year, the NZTA says it's money well spent.
We're seeing a reduction in wet road crashes on the highway over time.
It collects data in 15-kilometre blocks, but if the truck stops, then all that information's lost and must be redone. Travelling at speeds between 45 and 80 kilometres an hour, Kevin says he's copped a bit of flack from motorists.
On the one lane, they get stuck on us. We can't pull over and let them pass, so they think we're being a bit arrogant, but we're not.
So the NZTA's urging drivers to be patient, because after all, this truck could save your life. James Ransley, One News.
To pop up. All right, so let's make sure that we can move on to the next one. There we go. All right. We should be back up now. There we go.
Right, thanks, Ryland. So hopefully that just gave you a bit of an idea of some scenes of New Zealand and just the equipment in action there. Now, I'm just conscious of time, so I'm going to skip through these slides really quickly. We've done a lot of correlation of a whole lot of pieces of kit, and they all measure in different ways. And so really, I'd encourage you to just decide on the piece of kit that's appropriate for your environment and being comfortable with the level of data that comes out, the accuracy. We've done a whole lot of correlation trials, and as the next slide will show, a huge amount of variability in terms of what we get out of it. So there's no right or wrong answer. The key thing is they do all measure in different ways, and you can see here the SCRIM is the red line, the NORS meter is the green line, and the grip tester is the blue line. So again, they are all built differently for different reasons, and it's really important. That's why we've stuck with one piece of kit, which helps us get that consistency year on year. So in terms of treatments and materials, as I said, we predominantly have a sprayed chip seal surface in New Zealand. We do have asphaltic concrete in more of our heavily trafficked areas. We don't have concrete roads other than some very isolated patches in New Zealand. So typically relatively cheap chip seal surfaces on most of our highway network. And we then use high polystone value aggregates in our higher risk areas. And we've got a aggregate performance tool that we're now using to see what the performance of those aggregates has been. Previously, we specified PSV, but we found that wasn't always an accurate measure of the performance of the stone on the road. So we're now using the on-road history and that tool to then gives people an indication of what aggregate performs where. So as we move, and I'm sure you're aware environmentally that natural aggregates are getting harder to access. It's getting harder to extract from rivers and quarries. So we now also use melter slag. So this is coming from a byproduct from steel manufacture. And this is a very high PSV stone. We found it's performed very well. So while there's large transportation costs to get it to all parts of New Zealand, it has been a premium product that we have used. And then right at the top of the tree is calcined bauxite. Very, very expensive for us. Byproduct from aluminium manufacture, but incredibly effective in terms of providing an exceptionally high surface friction. And we used to talk about it back in the day as it's the same price as laying carpet on your road network, so extremely expensive, very labour intensive, has requires an epoxy binder to hold the stone to the road. And in terms of some of the other treatments, where we do have flushing or bleeding, we do use water blasting. So we'll go along and water blast the road and try and restore the both the macro and micro texture, which has been reasonably successful in terms of some of our treatments. So in terms of the monitoring and analysis, this is sort of the asset management component of managing a road network. The question must be how much and how often. And again, we've decided to go and do annually in each direction, but I'm sure these are the things that can be, as we said, we started once every 3 years. It's really your cut your cloth to suit because there's huge volumes of data. And some of your other condition measures don't change year on year as much as skid resistance does. But skid we find is quite variable. And if you want to have a proactive approach to it, it is good to get that information each year, and then you can target where the investment is. But we use that alongside all our other condition data and determine how we're going to and where we're going to invest. We've found that that bleeding does create a temporary surface contamination. In New Zealand, they use the term summer ice. So this is when the first shower of rain comes, the road's a bit contaminated and it's quite slippery. But that does wear off. So the underlying aggregate does then perform again in later months. The data we collect is used by other parties. So we do reports that are used in the coroner's court and for court evidence. So it's really important, again, that the accuracy of the data reflects the time of the survey and what happened on that day. But of course, obviously, in the dynamic environment, things are changing. So we've got to say, well, that was the survey, that was the result on the day, and then relate that to the time of the crash. And we obviously use trend data and looking year on year, and we look at what we call good skid exposure. So this is how much of our road is exposed to the volume of traffic that travels, and that's quite a good measure that people can understand around the percentage of the network or the percentage of the driving traffic that have been exposed to those skid resistance surfaces. Just a quick graph showing you what the results look like for that table I showed earlier. You can see there's site category 1, this is year on year. So initially it was quite poor, but level of investment is showing that we are making an improvement in those site category areas year on year. Now, one just little example I'll just go through just to demonstrate. This is a little bit older, but we have this 4-lane piece of road on the fringe of an urban area, very tight curve, and we were getting on average 11 crashes per month at this location. So incredibly high crash rate. We went in and put down our surface treatment, which was the epoxy with calcined bauxite. That crash rate dropped to between 1 and 2 per year. So it just proves that a real targeted treatment, premium solution can get a fantastic result in saving lives. And the next graph just shows when you do the measurement of friction, you can see there how that section of the network between 150 and 300 has got a far higher skid resistance reading than the other piece of the network either side. And the difference between those two lines is the seasonal factor. So you'll see that the top one was autumn and the lower one was spring. That's just showing that's how much variability you get between different times of year. The policy of success, what was the outcome? it's always useful with any policy to go back and look at the level of investment and what it's shown. And so what we've done is we've looked at the crash trend to prove that we have made a difference. And it's worth noting that this is alongside other safety initiatives. So it's always difficult to actually target and say the skid resistance improvement was the one that made the reduction in crashes, because we've got police doing enforcement, we've got other safety features, we've got improved vehicle on our network, we've got the amount of vehicle kilometres travelled, we've got the amount of time the road's wet, a whole lot of variables. But in doing so, this next graph will show that we think we can show that our skid policy has made a definitive difference. So these two lines are showing highways above and our local council roads below. And so what I'm highlighting here is local council roads don't measure as often as we do, so probably not as targeted in their treatment. But the downward trend there for highways shows for us that our wet road crash rate is dropping, and there's a notable trend there, and it's dropping at a far greater rate than on our local roads. So to us, that's looking at, we are one of the major contributors to reducing that wet road crash rate. So that's again proof that our policy is working, which is, it is actually all about saving lives. So the last slide in the session is the evolution of SCRIM. We've seen significant development since the 1990s, and as that TV clip showed, it's leading edge internationally in terms of the SCRIM development. We've helped work with WDM around some of those changes, moving from 1 to 2 wheels. We've got a network video. So initially, when we had the surface contamination, we needed to say, why are we getting a contamination? So we decided we'd take a photo every 5 meters or 14 feet, and that suddenly is now turned into a full network video every year. And the spin-off benefits are that a lot of other people can actually drive the network using the video and use it for other reasons. So they want to look at the signage or some other factor on the road environment. So that's one of the things that, one of the spin-off benefits from doing that. We've increased the speed of measurement. We're using significant laser profilometers across the road to give us a detailed road profile, texture, shape of the road. And obviously there's been a whole lot of other improvements in terms of water application, weight distribution, and GPS location. So we've worked hand in hand with WDM, and they've made some significant developments and advancements in their technology. That ends session 2, Rylan.
Thanks, Mark, and I really appreciate you kind of going through the material specification side. I think one of the key things that we end up talking about with a lot of people is, there are many solutions to potentially low friction. There's a wide range or ways of tackling that. And so I hope that that was one of the things, and that kind of plays into the next question I was asked. So I'm going to put you on the spot a little bit, Mark, and I'm conscious that we are short on time. So when I do, the question I have for you, I think may help kind of tie up some of the things that you are planning on talking about in the back end. But a core tenet of pavement friction management is something that you've said here as well, which is one size does not fit all. But I like to compare NZTA's approach to Transport Scotland's, which uses a different prioritization process, different thresholds for action and countermeasure selection, different material specifications, and so on. But there was a report out recently. The Transport Ministry is calling for increased maintenance funding, and have said that an historical emphasis on new construction and unanticipated increase in heavy vehicle traffic and a focus on sweating the asset has led to less than optimal network performance. And I think we're all broadly familiar with that pendulum. We invest in one place, it works, but then priorities shift, and we're kind of rushing to follow where we need to invest now. But one of the consequences of this is that NZTA's share of roads that require treatment due to low levels of skid resistance has actually increased as a percentage of all roads in recent years. So like the key question then really is, what are we optimizing to and how? And so, as you look back across this program, what are the key levers that you can use to adjust a pavement friction management program to meet changing needs or priorities or circumstances?
I think the world over, we're all competing for the precious dollar to invest in improving our road network. So it's really important, I think, to have the information, the data to back up the decision making, to justify why you need to make a difference. And for us, it was around having a targeted policy. And I encourage others to think about it to suit your environment. And you do need to justify it to your funders and your governors. So you've got to be able to have the evidence. And that was for us key, having evidence to show we think we could make a difference. And then by going back and proving that we did through the information and the statistics.
I think that is a superb answer. Now, I will say that we've got about 5 minutes left. So, Mark, I want to kind of put it to you. Do you want to make a run through the last section, and then for folks who have questions, kind of stay on for a little bit longer? It's early in your morning. It is late for some. Or do you want to kind of do a high-level synopsis, and then we'll close with a couple of polls and a question? Really, it's your call.